Hello, mathematicians. Here is the video for home connections, pages 13 and 14. Here we go. When you count by a number, you are naming multiples. Most people think of multiples as skip counting, okay? For example, if you skip count by fives, you are naming multiples of 5. And I just want you to notice that anytime something is a multiple of 5, for example, 5 times anything will get you a multiple of 5. So this is 5 times 1. 5 times 2, 5 times 3, 5 times 4, 5 times 5. Eventually you'd get to what 5 times 100 is, right? So you'd eventually get up there as a multiple. Okay, so a lot of times people think of multiples as skip counting. Here we go. In each sequence, fill in the missing multiples. So we have the example of 5 there. Let's do multiples of 3. So skip counting by 3. 3, 6, 9, 12, 15, 18, 21, and 24. And we're skip counting by 3. And notice that 3 times 1 is 3. 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8. And of course, we could keep going. Multiples keep going. Okay, letter B, multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. And of course, we could keep going and so on and so on. Multiples of 9, counting by 9s or multiplying 9 times all the counting numbers. 9 times 1 is 9. 9 times 2 is 18. 9 times 3, 9 times 4, 9 times 5, 9 times 6, and 9 times 7. All right, number 2, circle all the multiples of the number in each row. So some of them are not multiples of the number at the beginning, so we just have to find the ones that are multiples. All right, letter A is kind of right next door. So we're finding multiples of 2. And of course, they're all going to be even numbers, right? 2 times 3 will give me that. 2 times 4. Ooh, here's 2 times 7. Oh, here's 2 times 5. Notice that they're all even. The next one are multiples of 4. Here's 4 times 2. Here's 4 times 4. 4 times 5. 4 times 7. Here we go. Letter C, multiples of 7. Okay. 7 times 2 is right there. 7 times 3 is right there. 7 times 6 is right there, and 7 times 5 is right there. You could also count by 7s. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14. You know, count by 7s and get the numbers that way. All right, the next one says the number 8. So let's see, 8 times 1, 8 times 2. There it is. 8 times 3, I don't see 24. 8 times 4, I see. 8 times 5 is 40. 8 times 6, is 48. 8 times 7 is 56. I don't see that. 8 times 8, 64. No. 8 times 9. There we go. And finally, multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7. 3 times 8 is 24. 3 times 9 is 27. So it can't be 29 if I just said 27. 3 times 10 is 30. Then I think I'm just going to count after that. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Okay, I found them all. There we go. All right, moving on. Fill in the missing numbers. So remember that knowing our facts, that's why we do so many multiplication facts for morning work. So important. It'll make 5th grade feel much easier if you know most of these. 9 times 9, 81. 3 times 9, 27. 4 times 4 is 16. 2 times 6 is 12. 7 times 8, I always think 5, 6, 7, 8, 56. 3 times 8 is 24. 7 times 2 is 14. Let's come down a little further here. 6 times 5 is 30. 9 times 4 is 36, and 3 times 4 is 12. Oh, we've got more. Let's keep going down. All right, 6 times 2 is 12. 6 times 4 is 24. 6 times 8 is 48. 6 times 6 is 36. And 6 times 9 is 54. All right, let's go on to the next page. Home Connections, page 14. Let me make this a little bit bigger so we can see it. All right. Find the numbers in the sequence, which is the pattern. Start with 33. And the rule is to subtract 5. So notice that the 33 is already there. So now we need to go down by 5. So let's see, 33, 32, 31, 30, 29, 28. And if you can't do that in your head or on your fingers, you could definitely show a problem like that if that's easier for your brain. All right, let's subtract 5 again. 28 minus 5 is 23. Minus 5 is 18. Minus 5 is 13. Minus 5 is 8. And minus 5 is 3. Also, a lot of kids find adding easier. So start at the end and add. Is 3 plus 5 8? Yep. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5, yep, is 23. 23 plus 5 is 28. And 28 plus 5 is 33. So sometimes looking at it backward can be helpful too. Okay. What patterns do you notice? Why does this happen? Did anyone notice, and I bet that you did, that every other one ended in a 3 and the other ones ended in an 8? And the reason that is because we were subtracting 5, which means every other one we were subtracting 10. And that's why when you subtract 10, like from here to here, is a difference of 10. From here to here is a difference of 10. And that's why some of them ended in 3 and other ones ended in 8. So what patterns did you notice? Let's say some ended in 3, or had a 3 in the ones place, right? And some ended in 8. And again, the reason that is really is because from 33 to 23, right, that's a difference of 10. And from 28 to 18, like every other one, that's a difference of 10. Okay? All right, and when you subtract by 10, the number in the ones place is always the same. All right, 4 friends were making cards to sell. How nice. Each friend made 9 cards. Let me do some circling here. All right, so we've got 4 friends, and they make 9 cards each. They bundled all their cards into groups of 6 to sell. How many bundles of 6 cards did they make? Show your thinking. The first thing I want to do is that 4 friends times 9 cards each, and that equals 36. Okay, but that's not the answer because they're asking not how many cards there are total, but how many bundles of 6. This might be a great opportunity, especially if you're really visual like I am, to draw some things. So I'm going to make 36 cards and I'm going to put them in groups of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there are my 36 cards, but they need to be in bundles of 6. And the question is, how many bundles of 6? Well, there's one bundle of 6. There's another bundle of 6. There's another bundle of 6. There's another group of 6, another group of 6, and another group of 6. And there are 1, 2, 3, 4, 5, 6 bundles is the answer. So what we really did is we took 36 cards, divided into groups of 6. And that's how many bundles is our final answer. So 6 bundles. Let me read that question again. Sometimes in a long problem, I forget what they were asking. How many bundles of 6 did they make? Yep, I answered it correctly. 6 bundles of 6. All right, we got one more problem. Zach measured a rectangular garden at the park. The longer sides measured 15 feet. Dude, I am drawing a picture on this. That is for sure. All right, so I'm going to draw a park. And it says the longer sides were 15. So I'm going to label that. Okay, let me read again. The longer sides were 15 feet, and they were 3 times as long as the shorter sides. That means the shorter sides must be 5, because isn't 5 times 3 15? So that would make 15 3 times as long. Okay, if Zach walked all the way around the garden, how far did he walk? You know, I haven't tried this on our new Clever Touch. I wonder if it will work. I draw a little stick figure. Can I move that stick figure? Let's try. All right, let's walk around the garden. You ready? I can do it. All right, then let's walk here. Back up to the starting point. All right, Zach, I hope you had a great walk. So how far did he walk? That's finding, if you know this word, the perimeter of the shape. So 15 plus 5 plus 15 plus 5, adding all the sides together. And you can do it in any order. Okay, I know the 15 and the 15 is 30. The 5 and the 5 is 10, giving me a final answer of 40. And I'm going to label it, of course, 40 feet. All right, let me show you all the answers, starting with page 13. Here we go. And page 14. All right, mathematicians, great job. I'll see you in class.